Hello everybody, welcome to our YouTube channel. So if you haven't subscribed to our channel, please don't forget to do so to be part of the family. So today we are doing projectile motion. So let's look at this question. All right, so they are saying here a ball is thrown vertical upward from the top of a building with an initial velocity of 12 meters per second. The ball leaves the thrower's hand at a point that is 50 meters above the ground. All right. So the ball just misses the edge of the roof on its way down and it bounces off the ground. All right. So let's try to analyze this scenario. So we have a thrower here. So this thrower throws a ball with an initial velocity of 12 meters. So the ball's velocity is decreasing up until it reaches maximum height, and at maximum height the ball's velocity is 0. Then it gains the balls after reaching maximum height, it stops there, then it gains momentum, then it goes back again, goes back to the ground, because on its way down it misses the edge of the building, then suddenly hit the ground after some time. So why the velocity of the ball is decreasing, rather not increasing but decreasing. So it was projected at 12 meters per second, but after some time it will be 0. So it is decreasing because the acceleration that is acting on the ball is gravitational constant, and we know it is always pulling downward. So the direction of the motion of the ball is upward. So the ball is going upward. So its acceleration is pulling it downward. So we're going to choose this direction as negative and this direction as positive. All right. So when the ball on its way down, when it reaches the point where it was thrown, it will have a velocity of 12 meters per second, but in this time it will be negative because the ball is moving in the opposite direction. So we're going to treat the point where the ball was thrown or where the thrower is standing as our reference point or as our ground. So this will be our 0. This will be our 50 meters. So again we have a 0 and we have 50 meters. So we said the upward direction is positive. All right, so what does that mean? So it means if you are moving from this point to this point, so you will be moving in the positive direction. So if you move from this point to this point, you will be moving in the negative direction. So this will be 0, this will be negative 50, this will be 0, and this will be positive 50. So anything that is from the ground, no, from where the thrower is to the ground will be negative, and anything that is moving from the ground towards the thrower will be positive. All right, so let's attempt the questions now. So 3.1, we need to determine the time taken for the ball to reach maximum height when it is thrown. So let's collect data. So 3.1.1. So we know final velocity at maximum height, it will be 0. Then initial velocity is 12. Then time taken, we don't know is the one that we're looking for. And acceleration will be 9,8, but now it will be negative because the ball is going upward and the acceleration is going in the opposite direction. So let's check our formulas and which one fit perfectly or nicely. So this one, the first one, fit nicely because we know the final velocity, we know initial velocity, we know acceleration, and we don't know time, but the time is our quantity of interest or variable of interest. Okay, so according to that formula, okay, let me use different color. So V final will be equal to V initial plus A delta t. Then our V final is 0 at maximum height. Our initial velocity is 12. Our acceleration is minus 9,8. Then the time, we don't know. Then I'm going to transpose this 12 and it will be negative. When it crosses the equal sign, then I will have 9,8 times delta t. So if we divide by 9,8 both sides, so the time taken will be minus 12 over minus 9,8, which will be 1,22 seconds. All right, so the next question, determine the maximum height reached by the ball. Determine the maximum height reached by the ball above the ground when it is thrown. So, all right. So according to our data, we have initial velocity, we have final velocity at maximum height, we have gravitational constant, and we are looking for maximum height, and we also have time. So we can choose any formula with all these quantities. So let's use this one. This one, we have final velocity, we have initial velocity, we have acceleration, and we have displacement. So V final squared is equal to V initial squared plus 2A delta y. So our V final is 0 at maximum height. Our initial velocity is 12. Then our acceleration is minus 9,8 delta y. So 0 squared is 0, 12 squared is 144. 9,8 times 2 should be minus 19.6 delta y. So if we take 144 to other side of the equation, it will be negative. Then we're going to have minus 19.6 delta y. Then divide by 19.6, divide by 19.6, then delta y will be equal to minus 144 over minus 19.6, which is 7.346 or 7.35 meters. So this is the distance which was traveled by the ball from where the thrower was to maximum height. So it's that distance, but we need to determine the distance from the ground. So we need to add this 50 because when the ball was projected, it was already 50 meters above the ground. So we're going to say delta y max is going to be 50 plus 7.35, which is equal to 57.35 meters above the ground. Then next question, 3.1.3. So the velocity of the ball at 4 seconds at t is equal to 4 seconds or after 4 seconds. So again, we know final velocity 3.1.3. So v final, we're going to apply this formula. V final is equal to v initial plus a delta t. No, we don't know final velocity after 4 seconds. We don't know final velocity. So let's collect our data. So delta t is equal to 4 seconds. V initial is equal to 12 meters per second. Acceleration is equal to minus 9.8 meters per second. Then V final is the one that we are looking for. So we can apply this formula. V final is equal to V initial plus acceleration times delta t. So V final is the one that we are looking for. Our V initial is 12. Our acceleration is minus 9.8 because it is opposing the motion of the ball. So after 4 seconds, so our V final after 4 seconds will be 12 minus 9.8 times 4, which is minus 27.2 meters per second. All right, so final velocity is negative. That means the ball will be traveling downward after 4 seconds, because when it reaches maximum height, it will have a velocity of 0. Then it will change direction. So it will now start to move downward in the opposite direction. So it will have the velocity will be negative. This negative implies that the direction of the ball is downward. Then 3.1.4. Determine the position of the ball above the ground at 4 seconds. Determine the position of the ball above the ground at 4 seconds. So again, we need to collect our data. Okay, so delta y, the one that we're looking for. Delta t is 4 seconds. V initial is 12 meters per second. So V final is minus 27, 2 meters per second. So we need displacement. So we can apply any formula with displacement. So let's apply this one. Delta y is equal to V initial delta t plus half a delta t squared. So our V initial is 12, time is 4 seconds, plus half, our acceleration is minus 9.8, then our time is 4 squared. Then our delta y will be equal to 12 times 4, plus half minus 9,8 times 4 squared, which is minus 30.4 meters, which is negative, which then implies that the displacement is towards the ground. All right, okay, let me try to illustrate this via the diagram. So we have a thrower here. Then I'm going to treat the position where the thrower was as our 0. Then, okay, so the thrower was 50 meters above. So I'm going to have another 0 here as the ground. Okay, so let me put this 0 this side. Then I'm going to have negative 50 this side. So if you are here at the ground, so you move towards the thrower, so in the upward direction, so your displacement at some point, let's say here, let's say it's 40, so you will be 40 meters away from the ground towards the thrower, so in the positive direction. So if you are somewhere here, so let's say again 40, so now you will be moving in the negative direction away from the thrower. So you will be minus 40 meters away from the thrower because you are moving in the negative direction. So the negative displacement we are getting there simply implies that, so it's some distance away from the thrower. It's minus 30.4 meters away from the thrower, below the thrower, not above, but below the thrower. So this region over here is above the thrower, and this region over here it's below the thrower. So this 30.4 meters implies that this displacement will be the displacement of the ball below the thrower. So if we want, so the ball will be somewhere 30.4 meters below the thrower, which is negative. So if we want now the height above, so the distance of the ball, the height above the distance. Okay, let me see the question. The position of the ball above the ground. So this is the ground, this is the position of the ball above the ground. We know the height of the building is 50. So, and we know the distance which was traveled by the ball, it's 30.4 meters from the thrower at some point here, which is 30.4. So if we want this distance over here, so we're going to say this distance 50 minus this one, which we know is 30. Then we're going to get this one. So the height above, the distance where the ball is above the ground will be 50 minus 30.4, which is equal to 30.4, which is equal to 19.6 meters. So the ball will be 19.6 meters above the ground. All right. So On hitting the ground, 3.2, the next question. On hitting the ground, the ball bounces vertical upward with an initial velocity of 25 meters per second. All right. So initially, the ball was thrown with a speed of 12 meters per second. Then it reached the maximum height, then goes to the ground. Then when it reached the ground, it reached the ground with a velocity of 25. Then it bounced back, then it reached maximum height. Then we don't know what happened thereafter. So now we need to draw a velocity time graph for this occurrence. Okay, let me use different color. So the velocity time graph will be like this. So here we're going to have 0, here we're going to have positive, and here we're going to have negative. So on the x-axis we're going to have time, then on y-axis we're going to have velocity, which is measured in meters per second, and time, which is measured in seconds. So the ball started around 12 meters per second with a positive velocity. Then its velocity started to decrease up until it reached maximum height. So the velocity is decreasing up until it reached maximum height, where the velocity is 0. So we're going to have something like that. But it reached this maximum height after 1.22 seconds. So we need to show that. So then the velocity, or the ball, started to gain its momentum, and its velocity started to increase. But now in the opposite direction, because now the ball is moving downward. So it's the sign of the velocity is going to change from positive to negative. All right. So it reached the ground and bounced when it reached the ground with a velocity of 25, but this 25 is negative. All right. So when it bounced, so its velocity now is going to change again to be positive, because the ball will move upward. So with a velocity which is slightly less than 25, because it reached the ground with a velocity which was 25. Now when it bounces, it's going to bounce back with a velocity that is slightly less than 25. Then its velocity will decrease up until it reaches maximum height again, where the velocity will be 0. So that's the graph. Yeah, so we have indicated initial velocity when it was shown, initial velocity after the first bounce, and the time taken to reach its maximum height when the velocity when it was shown vertically. Yeah, that's